Hello everybody, let's continue our lesson. Okay, now we are going to discuss how to determine maximum and minimum points by using flowchart method. Okay, so for class discussion 1, okay, let's discuss the answer, the flow. Okay, so the question asks you to determine the turning points of each of the following and state whether it is a maximum or minimum point. Okay, so what is that mean? Okay, step 1, write your equation. So the equation is already given, okay, which is y equals to x cubed minus 4x squared plus 4x. Okay, so for this equation, okay, we want to determine the turning point. Okay, the turning point of the equation is maximum point or minimum point. Okay, step 2. Okay, I will explain further about what is maximum and minimum point. But before that, for step 2, sketch the graph based on the question, list all the information. Okay, from here we know, okay, this is the situation of maximum and minimum point. Okay, the curve, for example, this is example but not the real situation. Okay, so the lowest point, okay, is what we call is minimum point. Okay, so for x and y point, and the highest point of the curve is what we call it as maximum point. Okay, so x for point x and y, we do not know, okay, whether the lowest, okay, what is the lowest and the highest point. So that's what we are going to determine. Okay, so and then continue next, step 3. Okay, is it term by term? What is the meaning of term by term? Term by term meaning, okay, if we want to differentiate the equation. Okay, so there are 4 methods if we want to differentiate. Okay, first is term by term. Okay, so is it term by term? Okay, if you look at the equation, okay, it is term by term. But let's say if the equation is not term by term, okay, you can choose the second the second choice, which is no. Okay, if no, okay, follow the flow, and then the question asks you, can we use product rule? Okay, so this is another method how to differentiate the equation. Okay, if yes, okay, and then you continue with step 4. If no, alright, can we use quotient rule, another method to differentiate. And last one, if no, can we use chain rule? Okay, this is the last method how to differentiate. Okay, so actually this flowchart also show you the step or the method of differentiation, okay, from the first term by term to chain rule. Okay, so let's continue. Okay, let's say yes, is it term by terms? Yes. Okay, so here step 4, it tell you at the turning point. Okay, the turning point, okay, actually this is the turning point. Okay, at the turning point, which is maximum and minimum point, or the lowest or the highest point of the curve. Okay, please remember dy dx, okay, dy dx is equal to 0. Okay, in other said dy dx is actually gradient of tangent. Okay, so you have to differentiate the equation and then you simplify. Okay, so first differentiate the equation. Dy dx equals to 3x squared minus 8x plus 4. Okay, and then it tell you that at the turning point dy dx equals to 0, so equals to 0. Okay, and then as you can see, okay, this is actually a quadratic. So if the equation equals to 0, so what value can we get? Okay, so we can get the value of x by using factorization method. Okay, so I like to use this by using calculator. I like to use this like this. So identify the value of x first. So by using calculator, you will get x equals to 2/3 and x equals to 2. And then you fill up in the bracket. So 3x minus 2 and x minus 2. Okay, so what is the value of x? Okay, so we already get the value of x, which is x equals to 2/3 and 2 equals to 2. Okay, next step, step 5. Okay, find the coordinate of the turning point. Find the coordinates. Okay, as you can see, actually x equals to 2/3 and x equals to 2 is actually the value of whether this area or this. Okay, so how to determine the coordinate of turning point? Okay, we already got the value of x, so we want to find the value of y. Okay, right, so look at the equation of the curve. Okay, equation of the curve. Okay, from here, okay, if you know the value of x, okay, then we get the value of y. Okay, therefore when x equals to 2/3, therefore y equals to, and then substitute into the equation. Okay, it's 2/3 power of 3 minus 4 times 2/3 squared plus 4 times 2/3. Okay, and then you will get 32/27. Okay, and then when x equals to 2, so you substitute. Okay, so y equals to 2 power of 3 minus 4 times 2 squared plus 4 times 2, so you will get 0. Okay, so now, right, so now you get when x equals to 2/3, y equals to 32/27, and plus x equals to 2 and y equals to 0. Okay, next step, step 6. Okay, find the second derivative of the equation. Okay, second derivative meaning you differentiate for the second time of the equation. Okay, so why we want to differentiate this for the second time? Okay, what is the usage of the second derivative? Okay, so second derivative actually is to determine whether the equation, the turning point is maximum or minimum. Okay, let's say first dy dx equals to 3x squared minus 8x plus 4, and the second derivative x squared equals to 6x minus 8. Okay, so we must know the value of the second derivative actually show you whether maximum or minimum point. Okay, you know when x equals to 2 over 3, okay, the value of second derivative is negative 4. Okay, how do you get negative 4? Okay, so equals to 6 times 2 over 3 minus 8, so you get negative 4. Okay, 2. Okay, so the value of negative 4 is greater or less than 0. So negative 4 is less than 0, not greater than 0. So you must choose. So if less than 0, so okay, this is when x equals to 2 over 3, it is maximum point. Okay, now let's try if x equals to 2. Okay, equals to 6 times 2 minus 8, so equals to positive 4. So as you can see, 4 is greater than 0. Okay, and then okay, when x equals to 2 is minimum point. Okay, please take note, if x less than 0, which is negative number, okay, the x is maximum. Okay, and then when the value of second derivative is greater than 0, okay, that means x is minimum point. Okay, maximum point, minimum point. Okay, last step, state each point, identify the points. Okay, first, right, if x equals to 2 over 3, y equals to 32 over 27, and it is maximum point, not minimum. Okay, but then if x equals to 2, so y equals to 0, it is minimum point, not maximum. Okay, so this flowchart actually show you step by step until you can determine the value of maximum or minimum points. Okay, now let's look. Okay, this is another class discussion tool for you to try, and then a few exercise that you can train and that can you do as your homework. Okay, so let's try. Let's look example, further example. Okay, for you to as your reference. Okay, let's say this one. Okay, given L, okay, this is the equation. Find the value of x which L is minimum. Okay, from this question, okay, it is given that L is minimum. Okay, hence determine minimum value of L. Okay, so first what do we do is differentiate. Okay, differentiate dl respect to x. Okay, how to differentiate this equation? Okay, so let 3 pi, okay, outside the bracket. Okay, just this is actually take note, x power of -1, and then 2x plus negative 16x power of -2. Okay, and then just rearrange 3 pi, alright, 2x minus 16 over x squared. Okay, so because of L is minimum, so take note, dl equal to dx equal to 0, so equals to 0, and then okay, 3 pi, if you bring to the left hand side you will get 0. So now 2x, okay, minus 16 over x squared equals to 0. Okay, bring to the right. Okay, so 2x equals to 16 over x squared. Alright, and then we get 2x power of 3 equals to 16, x cubed equals to 16 divided by 2, so x cubed equals to 8. Therefore x equals to 2, which is it is minimum. Okay, how do I know? It is given. Okay, it is given in the question. Okay, so find the value of x. So this is the value of x, hence determine the value, the minimum value of L. Okay, so minimum value of L, okay, you know L equals to 3 pi, okay, times x squared plus 16 over x. Okay, and then substitute the value of x equals to 2 into the equation of L. Okay, so 3 pi times 2 squared plus 16 over 2. Okay, as you can see, every time I substitute the value of x, okay, I write down the bracket. Okay, remember that. So so you calculate, and then you will get the answer is 36 pi. Okay, alright, okay, that's all. Thank you.